Welcome back to another video on my YouTube channel. Today I will be solving some past paper questions on Hooke's law, so let's get started. Today I will be solving question 2 part A and B from the October-November 2021 session, paper 4 variant 2. Part A asks us to state Hooke's law. Alright, we know that Hooke's law states that the extension of a spring is directly proportional to the force applied until its limit of elasticity. This means that the extension of the object will always increase with the same rate as the force applied until it reaches its limit of elasticity, where it does not return to its original shape and is deformed. Figure 2.1 shows the extension load graph for a spring. On Figure 2.1, mark and label the region where the spring obeys Hooke's law. We already know that Hooke's law states that the extension increases or decreases directly proportional to the force. Therefore, you can mark an X on the starting of the line and 1 at where the load and the extension stop increasing directly proportional to each other, which would be 20.5 newtons. Your answer would be awarded a mark, even if your marking on the graph was just a bit off. Part 2 says to calculate the spring constant, K. Alright, let's recall the formula. K is equal to force divided by extension. Remember, to get the spring constant, we have to take the extension and the force from the exact limit of elasticity, which would be 20.5 newtons and 149 millimeters or 0.149 meters. Next, input the values into the equation. K is equal to 20.5 divided by 0.149, which would give us 137.58. Rounding that to two significant figures, we get 140 newtons per meters as our final answer. Part 3 states that the original length of the spring is 120 millimeters. Calculate the length of the spring when a load of 8.5 newtons is applied to the spring. Okay, we just have to add the original length and the extension at 8.5 newtons, as this would give us the length of the spring after it would be extended. If we look carefully at the graph, we can see that the extension at 8.5 newtons is 62 millimeters. So we can add 120 with 62. Which would give us 182 millimeters. It's alright if you read it as 61 or 63, you will still gain your mark. Thanks for watching. Please like and subscribe for more videos like this, and if you have any doubts, feel free to comment them down below. I'll be glad to answer.